All right, recording is rolling. It is Thursday, September 19th. You guys have back your linear motion quizzes. So real fast on those, let's get corrections opportunity. I threw this up on the board the other day. So this again, there are three main types of questions you might see. I like to ask graph questions. If you miss a graph question, this is if you want partial credit back. Just take out a spare piece of paper, draw the correct graph, label variables, units on the axes, the correct shape for the whatever story that happens. Okay. Sometimes I ask conceptual. I tend to ask my other classes more of these type questions where it's maybe harder to express in terms of an equation, but you can say right out of a sentence. You guys might get some of those sometimes. I ask quite a few of these, right? Algebra-based questions where you can solve it with an equation. So if you miss that type question, just go ahead and set up an equation, solve it that way. Now, you guys, AP, I also like to ask a lot of questions that tend to be like solved in terms of variables, so you get really general solutions, and also proportional questions like, what if Bob can throw it 3 times as fast as Alan, or those types of questions. So here, let me show you guys. I'm gonna flip my screen. This is just for you guys here. Since the quiz I give to AP is really harder than my other classes, I think it makes more sense to post the solutions. So guys, yesterday I did post the solutions here. If you guys go to Google Classroom, scroll back a few weeks to linear motion, and it's here. It's right here. So let me open in a new tab. I wanted to do at least one example with you guys. Of course, there's lots of actually I made different versions of the quiz with you guys got slightly different variations on questions, but all the solutions are here. I want to do and some of these I solve with graphs because you can solve it faster with graphs. I want to do at least a couple examples with you guys. Let me zoom in a little bit here. So many guys get this question. This I think this was either the last question or one of the very last questions on the quiz. Bob can throw a ball 3 times as high as Alan. Okay, if you can throw it 3 times as high, that means you can throw how many times as fast? Right? You guys see that's really broad open. I didn't give you guys any numbers. Right? You don't. So you could solve in terms of variables. You think, okay, make a little text VB checklist. Okay, what do I have? What do I want to know? Right, well, I know at maximum height would be final velocity would be 0. Maybe that could be helpful. At some point, you're going to stumble across this equation here, the third kinematic formula, the one that's time independent, sometimes you call it. Okay? And so, okay, here's your throwing speed based on throwing height. So if now if you know how high you can throw, you know exactly how fast you can throw. Is that right? Now, guys, take a look at this 3 times as high. If you and a friend get together, one you can throw it like 10 meters high, the other can throw it 30 meters high. That's 3 times as high. Guys, 3 times as high. If you slip a factor of 3 on that h, that's going to correspond to how many times as fast? Hold it. It's underneath the square root. What's the square root of a factor of 3? Square root of 3, which is like 1.73. If you got something like 1.73 times, it's an answer. Okay. Guys, here's the full version written up. Here's the speed Bob can throw, square root 2g 3h. Here's the speed Alan can throw, square root 2g h. Right, this all, see, it's all in terms of variables. Now I'm taking a ratio. What is Bob's throwing speed compared to Alan's throwing speed? You guys see that? Right? You guys see everything cancels except for this 3 that's underneath the radical. So it's a ratio of square root 3. You can cross multiply the speed that Alan can throw. There you go. Bob can go throw square root of 3 times the speed that Alan can throw, which is like 1.73 times the speed Alan. Guess that. Right? Now, you know what? Do you guys think you could just make up numbers and try it out? I think one of the earlier questions I asked you guys was kind of the exact same question, just it had numbers in it. So you just kind of peek to that part of the paper. So that'll be like, guys, if this was confusing, like, I don't know if I did that right or something, could you just make up numbers? Like, I could throw 10 meters high. My friend can throw 30 meters high, and then just like work it out and get the exact throwing speeds and then compare those direct throwing speeds. You guys could do that, right? Right. So yeah, if you are ever asked to solve in terms of variables, then that should work for any specific set of numbers. And you can just make up something. Right? Some of you guys did not get that question. Some of you guys got something a little different. You might have on your quiz, you might be saying, what, where's that? You might be looking at your quiz saying, I have a question that says this: Bob can throw a ball 3 times as fast as Alan can throw. Now that's a different scenario, right? Different scenario. Okay. Okay. Well, if you can throw 3 times as fast, then suppose they throw the ball straight upward. How many times as high? Right. It's a little bit different question. Now it's going to be the same equation. Right? It's the same equation type scenario, right? But except this time you're solving for h in terms of throwing speed. That's it. And you guys see I dash outlined that. Here, if I contrast, let me rewind a little bit. The question we've been looking at for the last few minutes has been kind of the opposite. If you know how high you can throw, how fast does that mean you're throwing? That's that square root 2gh. But if you solve for that h, let's fast forward. Okay, here's the new question. how high can you throw based on throwing speed, right? Which is kind of the same thing backwards. And now it looks like this. Is that okay? Right? Now, okay, now I see a squared relationship. So it's throwing speed squared is proportional to how high it can go. Because if you throw on a factor of 3 to that V, I can throw it 3 times as fast. That's going to correspond to how many times as high? What's 3 squared? That's 9 times as high. 9 times as high. Right? And if you want to see the full proof, here's just plug in. Here's speed Bob can throw is 3 times as fast as Alan. Here's the speed Alan can throw is his own speed of Alan. Sub A could be for Alan, right? Right. And then for how high? So I have got an equation up here. I've got an equation down here. I'm just taking a ratio of those two equations. A lot of stuff cancels. The throwing speed of Alan cancels. I got, of course, a factor there. The gravity field of the planet cancels. And then it works out like this. A bunch of stuff cancels. And oh, look at that. There's exactly the answer. Right? But again, you could make up numbers. Say, hey, what if Bob could throw 10 meters per second and sorry, let's say Alan can throw 10 meters per second and Bob can throw 30 meters per second, right? And you can actually just work out the numbers, and I can guarantee you're going to get 9 times the height, whatever those numbers work out to. Okay, so you could, is that right? All right, so there's